So good morning everyone.
Good morning, sir.
Good morning,
So can you see the screen? Is the screen visible to you?
Yes,
Yes,
sir.
Okay. So
Yes, sir.
we have studied till potential difference. All right. We have studied till potential difference in the previous class, and today, my dear, what's today's date? Today's date is 23rd of April and 2021, and today we are going to start our lecture from electric current. Okay, electric current. Chalo. Somebody has joined. Just excuse me. Let me join. Okay, Shweta Soren has joined. No problem. Chalo. Good morning, Shweta. Okay, see, what do you mean by electric current? First of all, you understand this. What do you mean by electric current? In the previous class, I have taught you regarding charge. Yes? And I've told you that charges are of two types. One is positive charge and one is negative charge. These are called as electron and these are called as protons. Yes? So what is electric current? Electric current is the flow of charge through a conductor. Okay, the flow of charge through a conductor is called as electric current. Students, you will write down these definitions properly in your copy. Now you understand. In classroom also I have said to you that when I teach, you just follow the note, follow these things properly. I will give this video link. You can make your own notes. Yes. Chalo. Follow flow of charge through a conductor is called as electric current. So if I tell you this is a wire, and in this wire, suppose I have attached a bulb here. Okay, one bulb I have attached. Okay, it's a bulb, and current is flowing through it. Current is flowing through it, and this bulb is glowing. Okay, that means what? What do you mean by electric current? Flow of charge. So charge is flowing through this conductor. Okay, the charge is flowing. Which charge? So electrons are flowing. Electrons are flowing. Okay, the electrons are flowing through this conductor. Okay, and that is called as electric current. So if somebody will ask you what is electric current, what you will say? So flow of charge through a conductor is called as electric current. Electric current is denoted by a symbol called as I. I is the symbol for electric current. Okay, symbol for electric current. Okay, all right. So you can see here that electric current, we can also say it is the rate of flow of charge. That is, we can say rate of flow of charge. Okay, so what is rate, my dear? Rate means whenever we are talking something with respect to time, okay, then we call it as rate of flow of charge. So you here also you can write down rate of flow of charge through a conductor is called as electric current, and we can write down current is I is equals to charge divided by time. So remember, I is equals to charge by time. So I have given you the formula of electric current. Come on, see here properly. Electric current is equals to charge by time, or we can say that I is equals to Q by T. What is Q, my dear? Q is the charge. Okay. Anybody has any problem till this portion? Anybody has any problem?
no, sir.
No, sir.
That's
No,
good.
sir.
That's good. That's good. Very good. Very good. Chalo. Okay. Now, as you have understood about the formula, then let me give you the unit. Unit is very important. Unit of electric current. So unit of electric current is, my dear, ampere. Ampere, denoted by capital A. Don't read it as ampere. It's not ampere. It is ampere. Yes, ampere is written after the name of a scientist. So the symbol will be a capital letter A. Okay, so ampere, A is the symbol of the unit. Okay, unit of electric current. Now, if I give you a question like this, that in a conductor, okay, suppose 20 coulomb charge flows in 5 seconds. What is the current? What is the current, my dear? Come on, tell me, what is the current? Okay, here given charge Q is equals to 20 coulomb time is given.
4
5
ampere.
seconds. That's good. Very good. Very good. We know that's a
4
I is
ampere.
equals to Q by T, and Q is 20, T is 5, it's 4 ampere. So like this we do. Okay, this type of numericals generally asked in 1 mark question. 1 mark questions. All right. Sure. That's good. If you have understood till this position, let me tell you what are the smaller units. Yes, smaller units. Smaller units. So what are the smaller units? Milliampere. Okay, 1 milliampere is equals to 10 to the power of minus 3 ampere. Okay, 1 microampere is equals to 10 to the power minus 6 ampere. Okay, several smaller units are there. All right, bigger units are also there. Okay, bigger units are also kiloampere. Yes, generally those things we will see whenever it is required. Yes, not required. Mainly you should know that ampere is the SI unit of electric current. This much, any problem? Up to this much, any problem, my dear? Okay.
No, sir.
There is a fact.
No,
There is
sir.
there is a
No,
fact.
sir.
There is a fact that you should know that why current flows. Why current flows. What is the cause? Why current flows? Okay. You see, we have. I have explained to you regarding the potential difference. Tell me yes or no. Potential difference I have applied. Okay. You see, due to this potential difference. Due to the potential difference, current flows in a circuit. Okay, so potential difference is the cause, and current flows due to the potential difference. Due to the potential difference. That is, current flows from higher potential to lower potential. Okay, to lower potential. As we know that water flows from, if I drop water from here, it will come down like this, na? Higher height to lower height. Similarly, current also flows from higher potential to lower potential. Tell me yes or no.
Yes, sir.
Current generally,
Yes,
if somebody will ask you why current flows due to the potential difference across the conductor. Okay, if there is a potential difference across the conductor, then only current flows. Okay, all right, this much all right.
Yes, sir.
Okay, so I have said you regarding current. Now you should know how to measure current, and how to detect current. First of all, you should know that is current is there or not in a circuit. Suppose I have given you a circuit, their current is there or not. That you have to understand first. That is, you have to detect current. Then if current is there, then how much current is there? You have to measure it. So how to measure and how to detect current? Remember, spelling mistake. Hold on. Detect. Current is detected by an instrument. Okay, by an instrument called as galvanometer. Remember, galvanometer is an instrument which is used to measure the electric current. It is used to detect the electric current. Sorry, I am repeating once again. Do not mistake this thing. Okay, electric current is detected by an instrument. That is, detection means what? Current is present or absent. Okay, current is there or not. That means detection is done with an instrument called as galvanometer, and galvanometer is somewhat like this. We write down like this, G. Okay, the symbol of galvanometer. Sure. Next, how to measure current? Measure current is also by an instrument called as ammeter. It is an instrument which is used to measure current. That is, how much is the current? 5 ampere, 10 ampere, 15 ampere. We are measuring this, and its symbol in the circuit is somewhat like this, A. Okay, have you understood? So the device used to detect current, a galvanometer, measure current, ammeter, and the device used to measure potential difference, my dear. Potential difference is measured by an instrument
Voltmeter.
called as, very good, fantastic. voltmeter. Not voltameter. It is not voltameter. Okay, it's voltmeter. Isn't it? Voltmeter denoted by capital V like this. Okay, somebody has joined. Just hold on. Let me check who has joined. Okay. So, have you understood, guys? How much we are studying? Are you understanding? Yes or no? Tell me. Are you understanding?
Yes, sir.
Yes,
Yes,
sir.
sir.
That's good. That's good. That's
Yes,
good.
sir.
Sure. That's good. Now, just wait for 2 minutes. Let me scroll it down. Then we can proceed further. Okay. Now you see. Okay. Now, the next thing that we should know about is what do you mean by electrical circuits? Okay, electrical circuit. Electrical circuit. Okay, what do you mean by electrical circuit, my dear? What is electrical circuit? It is a closed conducting path of wire where all the electrical appliances are connected. Okay, closed conducting path of wire where all the electrical appliances are connected as per requirement, and current flows through it. Current flows through it. I repeat, what is an electrical circuit? Sir, electrical circuit is a closed conducting path. Okay, it is a closed conducting path. What do you mean by closed conducting path? Like this. Closed path. There is no empty spaces. It's all closed. Yes, where all the electrical appliances are connected. All the electrical appliances means what? Sir, appliances which are all available in the market, we will bring all and we will connect. Not like that. Okay, all the electrical appliances which are as per requirement. So whatever you are what are the instruments that you require, that you will connect, and current should flow through it. That is called as electric circuit. For example, I want to switch a bulb. Okay, I want to glow a bulb. Then what to do? I will use a battery, my dear. I will take a battery and I will take a switch. Okay, what are these symbols that I am drawing? I will tell you. Okay, and after that I will use a bulb here. Okay, and what I will do? I will use a galvanometer here. Listen, that will measure the current. So whenever current will flow like this, the current will go from higher potential to lower potential outside. Isn't it? The current will go like this and it will glow the bulb. Okay, this is not a closed circuit, my dear. This is still not a closed circuit because here you can see that the switch is not closed, the switch is open. So here there is nothing. Here there is space is empty. So what you will do? You will close the switch like this. If you will close the switch, then what will happen? The circuit will become closed and current will flow like this. Have you understood? Have you understood what I tried to mean?
Yes,
Yes,
sir.
sir.
Okay, that's good. So
Sir.
if you have understood, then that's fine. And now what is required? We will study about the electrical symbols. Okay, electrical symbols are very, very important. Okay, just see. We are going to start with electrical symbols. Alright, electrical symbols. So the first symbol is somewhat like this. You will tell me what is this. Okay, one by one. I will ask you. 1, 2. The students are joining like this. Okay, number 2. Still somebody has joined. Just hold on. This disturbs the class. Khushi Parekh. Khushi. Khushi, can you listen to me? Okay. Just hold on. Let me draw all the electrical, what I can say, the symbols. then we will see what are those. Okay. So this much I think will be sufficient for you. If you feel that something else is also there, you can tell me. Okay, we just see here. Okay, one by one. What is this, my dear? This is called as a cell. This is cell. Okay, this is the symbol of a cell. The pencil battery that you see at your home, that you put inside a remote, yes, of TV, any remote control, you put the pencil batteries. You know, yes or no? Tell me.
Yes, sir.
Those are not batteries.
Yes, sir.
Those are not batteries. We should call them as cell. Okay, that is cell. And what is this, my dear? This is battery. This is battery. Okay. What is battery? What is the difference between cell and battery? When two or more than two cells are connected, they are called as battery. Yes or no? So when two or more than two cells are connected, we call it as battery. Understood? This much understood?
Yes, sir.
My dear,
Yes,
this
sir.
is
Yes,
the
sir.
this is the symbol of
Yes, sir.
resistance. This is the symbol of resistance. Okay, this is the symbol of variable resistance. Variable resistance. Okay, or it is called as rheostat. Rheostat. Sir, why you have drawn two things? 1, 2 like this? Yes, both are the symbols of variable resistance and rheostat. Both are same. Variable resistance and rheostat both are same thing, and their symbols can be drawn like this. The two both are the symbols of the variable resistance and rheostat. Understood? Next, this one I have said you right now. This is ammeter. Yes, this is voltmeter. This is galvanometer. Okay, this is open switch. Open switch. Yes. Now, sir, again two diagrams. Yes. So in several circuit diagram we will get like this, and others will get like this. Yes. So both are the diagrams of open switch. From open switch, remember, no current flows. No current flows. Yes. In open switch, no current flows. Yes. What do you mean by open switch? Generally, we say at our home that close the switch, the fan is moving. Uselessly the fan is moving. We tell that just close the switch. Okay, then what you do, you go to the switchboard and you close the switch. Yes, that is not called closed. That is actually we used to open the switch. Yes or no? That is open switch. Understood? We are breaking the circuit, and this is called as the closed switch. So till today we used to say all the opposite things. Yes. Again, both are the. I'm sorry. I've tried wrong diagram here. The symbol will not be like this. The symbol is somewhat. It's a straight line. Okay, a straight line like this. Okay, this joint. Okay, that is closed switch. Generally use this one. Okay, one bracket with one full stop is a closed switch, and one bracket with nothing is a open switch. Now this is the symbol of a bulb. This is the symbol of a bulb. So have you understood what are the different symbols and what they mean? Yes, is this clear to you? Is this clear?
Sir.
Yes, sir.
Yes, sir.
Everyone, absolutely clear. Any problem?
Yes, sir. No, sir.
That's good. If you have no problem, then that's fine. Okay? Sure. So we have completed the symbols also. As we have completed the symbols, now what, sir? Now which topic we are going to move? Tell me what we can study now. We can study now, my dear, Ohm's law. O-H-M'(S), Ohm's law. Ohm was a scientist and he has formulated a law, and that's called as Ohm's law. Okay? Ohm's law has some bindings. It has some restrictions. So what are the restrictions, sir? He has said Ohm's law is valid. This law is valid when temperature is constant. Okay? Temperature is constant. If you will vary the temperature, then this law will not valid. Okay? This law will not stay valid if you vary the temperature. So Ohm's has said that you keep the temperature constant and my law is valid. Okay? Have you understood? Okay? Now let's see what Ohm's law states. Okay? What Ohm's law states, let's see that. He said that at constant temperature, come on, follow this problem. At constant temperature, okay, the current flowing through a conductor, is directly proportional to the, at constant temperature, the current flowing through a conductor is directly proportional to the potential difference applied across its ends. Applied across, I'm sorry, just hold on. Applied across its ends. Okay, just see. At constant temperature, the current flowing through a conductor is directly proportional to the potential difference applied across its ends. Just before some time, I have said you one thing, that current flows due to the potential difference. Yes, I have said you. Do you agree with this or not? Yes, right now I have told you that current flows due to the potential difference. Now you can see here what Ohm has said, what Ohm's law has said, that current flowing through a conductor, that is, the current will flow. How and when? When it is, and the current will flow when potential difference exists, and the amount of current is directly proportional to the potential difference. That is, I is proportional to V. That is, if you increase the potential difference, current will also increase. If you decrease the potential difference, current will also decrease. Have you understood? Yes or no? So at constant
Yes,
temperature,
sir.
but
Yes,
this
sir.
is valid when?
Yes,
This
sir.
is valid. This is valid when temperature is constant. Okay? This temperature should be constant. If temperature varies, then sir, I will not be proportional to V. Then I will vary. Okay? So let me tell you that I is proportional to V is given by Ohm's law. Now let's study bit more in this section. Okay? You should know something more in this section, that is, I is proportional to V. So similarly we can write down, sir, V is proportional to I. Yes or no? If I is proportional to V, then you can write down, sir, V is proportional to I.
Yes, sir.
Yes,
sir.
Somebody has joined? No. Okay. Let's come back. If I is proportional to V, then we can write down V is proportional to I. My dear, we cannot, this symbol is given for proportionality. Proportionality symbol. Okay. And you have to change that in equals to sign. So to change the proportionality into equals to sign, we have to add a constant. Remember, we always have to add a constant. That means V is equals to, we cannot write down I. We have to add a constant here. Okay, just hold on. The battery is running low. Okay, just hold on. Just wait. Okay. Excuse me, students. Sorry for the disturbance. Are you all there?
Yes, sir.
Yes, sir.
Yes,
Yes,
everybody
Yes,
is here?
sir.
That's good. That's good. My battery was running out. I have switched on the charger. Anyways, chalo, let's come back. Okay. So, my dear students, I was telling that V is proportional to I, and to change that into equals to sign, we cannot write down V is equals to I directly. No, we have to take a constant here also. So, V is equals to IR. Sir, what is R? What is this R? So, this is the proportionality constant. Proportionality constant. Okay, and this proportionality constant is called as, my dear, very important thing that you are going to study, and that is, my dear, resistance. Resistance. From here, the concept of resistance is starting. From here, the concept of resistance has started. Okay, so what you have come to know? You have come to know from Ohm's law, that's a V equals to IR. This is the formula of Ohm's law. This is the formula of Ohm's law. Anybody has any problem? Sir, V means what? V means, sir, potential difference. Okay. What is I, sir? I means, sir, current. Okay. And what is R, sir? R means resistance. Yes. This much clear? V equals to IR. So if somebody will ask you, what is the formula of Ohm's law? What you will say? The formula of Ohm's law is V equals to IR. Yes. This much? Understood?
Yes, sir.
Yes, sir.
Yes. But this is valid until and only when temperature is constant. Okay? Clear?
Yes,
Clear?
sir.
Okay. That's good.
Yes, sir.
That's good. Chalo. Now, Now, if I tell you, sir, you have told me about potential difference, you have explained, okay. Sir, current you have explained, okay. But what is resistance? So for that we have to study resistance, okay. Let's study resistance. Resistance. My dear, what is resistance? Resistance is what? Resistance is a property of matter which obstructs the flow of current. Okay, so what is resistance? Resistance is a property of matter which obstructs the flow of current. That is, resistance is such a property which do not allow current to flow. Obstruct means, what is obstruction? Obstruct means do not allow. Do not allow. Okay, if I tell you what is resistance? Resistance is a property of matter. Every matter has a property called as resistance. Every matter. You, me, table, fan, pen, pencil, blackboard, laptop, everything. Okay, resistance is a property of matter which do not allow the current to flow. Understood? Few material has less resistance. Few material has less resistance, though they are called as conductors, and few materials has very high resistance and they are called as insulator. Have you understood? Any problem?
No, sir.
No, sir.
Very easy.
No, sir.
Okay, everybody has resistance. Table, chair, me, you, everything. Okay, this is called as resistance. So resistance is a property of matter. Since everybody has, that means resistance is a property of matter. And what does it do? It restricts. That is, it obstructs. It do not allow the current to flow, and that is called as resistance. Is that clear? Is that clear?
Yes, sir.
So what is the formula
Yes.
of resistance? What is the formula of resistance?
Yes.
So you have given, sir, V equals to IR.
V by I.
Very easy, sir. R is equals to V by I. Less, sir. Very easy. You can take like this. Okay. Very easy. Sir, what will be the, sir, unit? What is the unit? Unit of resistance. Very important. Unit of resistance, my dear. Okay. Very important unit of resistance. Sir, you can say from here only, unit of potential difference is volt, unit of current is ampere. So we can say that the unit of resistance, so unit of resistance we can say volt per ampere. Volt per ampere we can say, yes or no? Or we can say volt per ampere. Generally we don't use. What we use? We use as ohm. O-H-M. Ohm. Ohm is the, oh sir, you have written in capital letters, so always we will write in capital letter. No, not like that. I'm just explaining it to you. That's why I have used the capital letter. Okay? Understood? Chalo. So what is the unit of Ohm's law? So the SI unit of Ohm's law is which one? Is Ohm. O-H-M, denoted by like this. This symbol. This symbol means what? Ohm. Omega. Okay? Understood? So, the property of matter which obstructs the flow of current is called as resistance. Formula R equals to V by I. Resistance unit is volt per ampere or ohm. Yes? This much clear?
Yes, sir.
Yes, sir.
Very good. Sure. If this much is clear,
Yes, sir.
sir, if somebody will ask you this question like this, suppose there is a question I have given you. Okay, the question is the potential difference given is suppose 20 volt and current is given as 5 ampere. So the resistance will be V by I and it will be 20 by 5. It will be 4 ohm. So you can find out. But my target is not to give you this because this is very simple question and nobody will ask you this. Okay? Nobody will ask you this. Okay? So what is my target? My target is to, if somebody will ask you that how to find out resistance, my dear, graphically how you will find out resistance. Okay, so how to find out resistance graphically, let's see now. Okay, let's see now. Suppose I am giving you a table like this. Okay, one side is potential difference, another side is current given. Suppose 20 volt 5 ampere, 30 volt 10 ampere, 40 volt 15 ampere, 50 volt 20 ampere. Understood? This is a table given to you. Okay? Alright? This much clear? This much clear?
Yes, sir.
Yes,
Okay.
sir.
If I tell
Yes,
you that draw a graph of it, sir, very easy. Very easy, sir. We can draw a graph like this. What is that graph? VI graph. Okay. VI graph you can draw. Okay, this is chalo 20, 40, 30, 40, 50 like this. Okay, and here also I like this 5, 10, 15, 20 like this. So what you will get? What you will get, sir? It will be a straight line. If I plot it, it will be like this. 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 So it will be a straight line graph passing from the origin. Tell me yes or no. It will be a straight line graph passing from the origin. Yes. So if somebody will ask you, how the graph between potential difference and current looks like, how the graph between potential difference V and current I looks like, you will say the graph is a straight line graph passing from the origin. Understood? It will be a straight line graph. You can see that the graph is straight and it is passing from the origin. Have you understood? Okay. Yes, everyone? Is this clear?
Okay.
Yes, sir.
Now you see, my dear. Now you see. If I take these 2 points, this point and this point, and similarly, I am taking their current value. Okay, suppose this is 20 volt and this is 40 volt and this is 5 ampere and this is 15 ampere. Alright, these 2 points I have taken, and I have asked you that find me the slope from the graph. I have asked you find me the slope from the graph. If somebody will ask you to find the slope, or if will ask you what does the slope of this graph shows, just hold on for a moment. I am coming. Just hold on. Hello, are you all there? Yes.
Yes, sir.
Okay, that's good. If somebody will ask you to find out the slope, then what you will do? Sir, what is slope? What is slope? You will first of all you ask me, sir, what is slope? Okay, let me give you an instance. Let me draw a mountain like this. Yes, like this, and let me draw a mountain like this. Okay, both are the mountain. Mountain number A, mountain number B. Now you tell me which mountain is easy to climb and which mountain is tough to climb. Come on, tell me first. Which mountain is easy to climb and which mountain is tough? B. B is what? Easy or tough? B is what? Easy or tough? B is what? Easy or tough? Easy. And A will be tough. A will be tough to climb. Yes or no? So remember like this. Slope means what is the inclination? What is the inclination? Theta. Okay, what is the inclination? Theta. Okay, remember. So B is easy to climb. That means what? The slope is less. The slope is less. You can see the slope is less. Yes or no? And A is tough to climb. That means what? The slope is higher. Slope is higher. Okay? So what is slope? Slope means the inclination. How much is the inclination? Yes? You see here. So to find out the inclination, what we should know? Whenever, suppose you are standing here. Suppose you are standing here and you need to reach this position. Mount Everest. You need to reach this position. Can you see? You are at position number P. I need to reach the position number Q. Then what you will see first? Sir, first of all, I will see how much height is. First of all, I will see how much height is. Tell me yes or no. You will see the height or not? You will see the height or not?
Yes, sir.
Yes. First of all, you will see the height. Then you will tell me, sir, I will see not only height, I will see how much far it is. How much far it is also I will see. Tell me yes or no. First of all, you will see how much height is. Then you will see how much far it is. Yes or no? So, to climb, to reach the height, you will find out the height first, then you will see the how much is the length of it. Yes or no? So, to find out the slope, that is this theta, you need the help of height and you need the help of L. That means slope is nothing but, my dear, tan theta. Slope is nothing but trigonometric ratio. Okay, trigonometric ratio. Slope is what? So, tan theta. And tan theta means nothing else than height by base. Height by, very easy. In a triangle, suppose I take a triangle like this. Okay, you imagine that this is the triangle that I have taken. In this triangle, sir, what is the height? So this is the height. What is the base? So this is the base. So divide this. Divide this. You will find out. Okay, 40 minus 20. You do 40 minus 20 divided by 15 minus 5. 15 minus 5. Sir, 40 minus 20 is 20. 15 minus 5 is, sir, 10. So 10, 22. So answer will be, sir, 2 ohm. Okay? Answer will be what? 2. Let me tell you how, sir, ohm, why, sir, ohm has come. Okay, just hold on. Okay, the answer is 2. Up to 2 is clear. Tell me, up to 2 is this clear?
Yes, sir.
Okay.
Yes,
Now
sir.
you see, sir, 40 minus 20. What is this? My dear, 40 minus 20, what is this? This 40 minus 20 is potential difference, V. And this 15 minus 5 is what? This 15 minus 5 is I. So I can say that 20 by 10 means what, sir? V by I. And what is V by I? Sir, V by I means R. And you have got the answer as 2. That means what? 2 ohm. So we can say that the slope of VI graph, the slope of VI graph will give you what? Sir, resistance. Is that clear? The slope of VI graph will give you what? Sir, resistance. Anybody has any problem? Anybody has any problem? This much is clear? Is this much clear?
Yes, sir.
Sir,
Okay. Yes.
Sir.
Tell me.
sir. So why we've taken only 15 and 5 if we have to know the slope?
No, not like
Why
this.
can't we take the whole one?
I have taken just as an example, 5 and 15 or 20 and 40. Anyone I have to choose. Na? I have just chosen this. Simply, I have chosen. You can take the example of
Sir, if
20, 30,
anyone-
20, 30 or 5, 10. Yes? Tell me.
So anyone we take will get the same answer.
Same answer. But here you will see, sir, how, sir, same answer. You see 50 minus 40 is, sir, 10, and 45 minus what I've written here, 5, 10, 15, 20. 20 minus 15 is 5. You will see that 5 2s are 10. See again, sir, 2 is the answer. Okay? Have you checked like this? Okay? This much clear? 40
Yes,
minus
sir.
30, sir. 40 minus 30 is 10, and 15 minus 10 is, sir, again 5. So 5 2s are 10. Okay? So you have to choose wisely. You have to choose wisely. So whatever we have studied today, let's revise first in just 30 seconds and we will just close the class here. You have a second class. Okay? So see whatever we have studied here today. Whatever we have studied here, just see it once. Okay? We have started the class with electric current. Okay? So you have studied about electric current. Electric current I is equals to charge by time. Unit is ampere. Smaller units we have studied. We have studied that current flows from higher potential to lower potential. Then we have studied the instrument used to detect is galvanometer, measure is ammeter. Yes, voltmeter is used to measure the potential difference. We have studied about electric circuit. Yes, we have studied about the different symbols, what do they mean. Ohm's law we have studied, and we know that temperature has to be constant. I is proportional to V and V equals to IR, where R is the resistance. We have studied about resistance, unit of resistance. Graphically how to find out resistance we have learned. So till this much we have studied. Still, if anybody has any problem, tell me. Anybody has got any problem?
No, sir. No, sir.
So have
No,
you
sir.
enjoyed
No,
the
sir.
class? Have you enjoyed the class? Is this all right? Have you understood everything?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Then thank you for today, students. In the next class, I will continue from the factors affecting resistance. Okay? Thank you. Come on, take care. Bye-bye. Stay safe.